Hello students, this is the review for Spiral 4. We're going to start off with looking at quadratic functions and their zeros. So this is the last time we're going to see this, so if you improve your grade here, that'll improve your grade in the first one as well. So we've got 3x squared plus 12x minus 15. We got to do some stuff with this. First off, we got to try to factor this or explain why it's not factorable. I'm going to rewrite this here just so I have a little bit of room. All right, so we got 3x squared plus 12x and minus 15. First thing I'm going to do is to break up my middle term, and I'm going to do that by finding things that multiply to a times c. So that's negative 15 times 3 is negative 45. And then my b value is 12. So I'm going to find things that multiply to negative 45 and add up to 12. Let's start with 1. So we got 1 times negative 45. That adds up to negative 44. Not going to work for us. 2 does not go into 45. How about 3 times negative 15? Ooh, that gets us negative 12, so that's real close. What if I do negative 3 and positive 15? That gets me a positive 12. Those are the values I'm going to break my 12 up into. So let's rewrite this. 3x squared and minus 15. I'm going to keep Luke because those are not changing. The minus 3 is going to become minus 3x. And plus 15 is going to become plus 15x. Cool. Let's get to factoring. For my first pair, I'm going to try to make a distribution problem that will produce this. I've got a 3 in common, and both of these also have an x. When I distribute that in, I need an x to be there to get 3x squared, and I need a minus 1 to get minus 3x. To get 15x minus 15, both of those have a 15. Let's take that out. And when I do that, I end up with an x and a minus 1. Hey, we got the same thing in both parentheses. That's a good sign. So x minus 1 is going to come out front. And then we have 3x plus 15. Cool. At this point, we are now factored. Depending on how you factored, you might have ended up with a couple of different versions of this because of the way this problem is set up. So instead of x minus 1, you might have gotten 3x minus 3. And if you did that, that would end up with x plus 5 in your other parentheses, and that's totally fine. As a third way that this might have shown up, if you divided by 3 at the beginning and factored that all the way out, we end up with something that looks a little bit different, where we'd have an x minus 1 and an x plus 5. Any of those three things mean exactly the same thing. You're going to get the same values for all the answers here based on that. To identify the y-intercept, the first thing I need to know is that when we have a y-intercept, that's when x is equal to 0. And I'm going to plug that into my original equation just because that will get me an answer very quickly. 3 times 0 squared plus 12 times 0 minus 15 ends up giving us negative 15 as a value. You might also have noticed that this is in general or standard form, and the last number there, the c value, is going to be our y-intercept. All right, so let's find the x-intercepts. That's where we take each parentheses, set them equal to 0. So I'm going to start with the ones that I did. All three will get you the same exact answers. So we get x minus 1 is equal to 0. And when I solve that, we get x is equal to 1. I'm going to write that as 0.1 comma 0. We've got 3x plus 15 is equal to 0. If I minus 15 to both sides, we get 3x equals negative 15. And then we get x is equal to negative 5. So that would be the point negative 5 comma 0. Because we found the x-intercepts, these are also the zeros. So I can literally just write x equals 1 and x equals negative 5. The only time those are different is if we have a graph that does not have x-intercepts. Then our zeros are imaginary, and we have to work with that. So we got to sketch a graph using important points. I'm going to include my zeros. We've got a 0 at 1. I'm also going to label them with the values. 0 at negative 5. We have a y-intercept, and the y-intercept, I think it was at negative 15. It was. So somewhere between these 2 points, we've got to have an axis of symmetry. I'm just going to go exactly in the middle. I could identify that if I find the average of those points. That would be at negative 2, but I'm not going to make you do that for this sketch. So my parabola should look something like this, where we have a minimum somewhere between our 2 points. It's not at the y-axis because that's not exactly in the middle of those two. That's just a point that's going to be kind of on the way. So if you use that as the vertex, you'd probably lose a point. If you end up with some kind of weird diagonal graph, you'd probably lose a point as well. But at this point, this problem is complete. On the next page, we've got stuff from I Want to Believe. We're going to start off with some work with imaginary numbers and then kind of go from there to solving using completing the square. So let's do our imaginary number stuff first. When we're combining complex numbers by adding, and that's what we're doing between these two, what that really means is that we are combining like terms. So I'm going to kind of make that association here. And then we've got a 2 plus a 5, and we've got a 3i plus a negative 2i. Okay, 2 plus 5 is 7. 3i plus negative 2i is plus 1i. And at this point, your problem is done. For the next one, I've got two parentheses. I've got to multiply between them. So I'm going to just put a note to myself. Multiply is going to tell us to do some distribution. All right, let's do this up. So we've got 2 times 5 is 10. We've got 2 times minus 2i is minus 4i. We've got 3i times 5 is plus 15i. And we've got 3i times minus 2i is minus 6i squared. Okay, and that reminds me of something. When we have an I squared, we have to do something a little bit weird because I squared is equal to negative 1. So in my next step, when I kind of go and rewrite, I'm going to combine my middle terms. You've got plus 11i when I combine those. And then I'm going to have minus 6, but instead of I squared, I'm going to write negative 1. What that lets me do is to rewrite this as 10 plus 11i minus 6 times minus 1 is plus 6. And now we can combine 10 and 6 to get 16 plus 11i. Moving on to the graphing question. We're talking about how many real zeros we expect based on the graph below and how many imaginary. So the first thing I notice is that this graph has no x-intercepts. That tells me that there are no, I'm going to write no instead of 0 because I'm going to say no real zeros, and 0 real zeros is just kind of a weird way to phrase that. So no real zeros, and if we have no real zeros, that means we have 2 imaginary zeros. If I had had something that looks like this, where I might hit the x-axis once, that would be 1 x-intercept would be 1 0. It'd actually be 2 zeros where they're the same number, but that's okay. And if I had another version, this one would have 2 x-intercepts, therefore would have 2 zeros. I'm going to use the word real there because we have 2 zeros in the red one as well. They're just imaginary. All right. And then finally, we're going to go into do some completing the square. I'm just going to zoom in so we can deal with this. We know that our first step in completing the square is always cleanup. So I want my equation to look like x squared plus something x is equal to stuff. And right now, our equation definitely does not look like that. The stuff that prevents it from looking like that are that 2 out front and this minus 12 here. The first thing that I might do would be to add 12 to the other side, because that's what we're comfortable with solving things. And when we do that, we get 2x squared plus 8x is equal to 12. Okay, the next thing I notice, I still have to get rid of this 2. I've got 2 times x squared. So what I'm going to do with this is to divide my entire equation by 2. That means I'm going to divide the left by 2. I'm going to divide the right by 2. This is a little bit tricky. We have to be a little bit careful with this because when we divide, we have to divide all the pieces. So 2x squared divided by 2 would be x squared. 8x divided by 2 would be 4x. And on the other side, we've got 12 divided by 2 is 6. At this point, we have completed our cleanup step and we're on to the next part, which is going to be completing the square. So for completing the square, our goal is to make something that looks like a perfect square polynomial. And the way that we're going to do this is going to be kind of weird in terms of just kind of the order that we do the math, but I think this is about the easiest way we can kind of figure this out. So what we have now is we've got this x squared plus bx is equal to stuff. And what we're going to do is to convert this into some parentheses so that we have an x and an x. And one of the things that we've spent some time talking about with completing the square is that in the parentheses, what we're going to do is divide the b up into two equal pieces. That way we get the same thing in both parentheses. So when we do that, we have plus b over 2, so whatever that number is, divide by 2. And then we're doing the same thing here, plus b over 2. I'm also leaving some space between these because we're going to work backwards a little bit to kind of fill in the blanks here. So I'm going to start down here, and I've got my x plus, and I've got my x and plus, and I see that my b is 4, so I'm going to divide that by 2 to get 2. So on both of those, we're adding 2. Okay, then I'm going to distribute going up for this, because we've got to figure out how to make this into the thing we have down below. This is what we want, and that's not what we have currently. So let's do some distribution. X times x gives me x squared. Then we've got x times plus 2 is plus 2x. Then we've got 2 times x is plus 2x. And we've got 2 times 2 is plus 4. If I were to combine those, that gives me an x squared plus 4x, because I'm going to combine those two, and then plus 4. And what I notice is that I don't have the plus 4 up above. Because of that, on the other side of the equation, I'm going to do 6 and plus 4 as well. The goal here is to figure out how to make the stuff we have down in blue. And the way that we're going to do that is by going through and just checking to see, first kind of creating that set of parentheses and then multiplying backwards to see what we have to add to both sides. When we did this out, that plus 4 showed up, so that's what I had to add to my original equation. And if I do that on the left, I have to do that on the right as well. Okay, so now I'm going to kind of copy down the other side of the equation. So 6 plus 4 is 10, and then keep that here. We get 10. When we're completing the square, we end up with this step where we have these things that are written in this way, and I can rewrite that, and I need to rewrite that as x plus 2 squared is equal to 10. And from here, what we're going to do is to solve the problem. Just put an up arrow there to remind us that we're working up from that step. So to solve this problem, I've got this stuff squared equals 10. I've got to take the square root of both sides. So I'm going to call this solve. The first note I'm going to put is square root. And the second note I'm going to put has to do with this next piece, because if we square root both sides, the left is x plus 2. The right doesn't have a nice square root, so we're going to leave that as the square root of 10. But if you're thinking about, well, Mr. Carlson, you're missing something, because in class we always talked about when you take your own square root, you need a plus and a minus. That's the other thing I'm going to write. We absolutely need that negative expression as well. So we got x plus 2, and instead of positive root 10, we're going to have negative root 10. To finish this up, we've got to solve both equations for x. I'm going to minus 2 to both sides. Those don't combine. So we end up getting root 10 minus 2. And the same thing on the other side. And when I do that, we end up getting negative root 10 minus 2. At this point, that's the end of the problem. We've solved, and we're done.